All right, so let's look at number 1 first. Excuse me. Let's just make sure we are good with the general form. I'll put it up here on the right, and we'll just do y equals instead of f of x equals, because we have y there. A sine parenthesis b x minus c parenthesis bracket plus d. So what that says is A is our amplitude, B is what determines our period, C is our horizontal shift, D is our vertical shift. B, note, needs to be factored out in order to have the correct B and the correct C. Now, if it isn't factored out, this would be the correct B value. This isn't that correct C value. This wouldn't be the correct C value if this was distributed in terms of what is the actual phase or horizontal shift. All that the reason I said all that is we have this x over 2, and you're going to have to factor out that half. Also, this 2 out front is our d over here, so it's just written in a different order, but just to make sure we understand that this 2 out front is the d value. If you want to put it after, you can go ahead and do that. First, we need to factor out that half. So when we factor out the half, we get an x plus. Now, if we factor out a half out of the denominator, we multiply the numerator by this number. I'll explain that more in detail in a second. So if I multiply this by 2, that would give us 2 over 4, or 1/2. Another way you could look at it is if I have a half out here, what do I need right here to get 1/4? Meaning when I distribute that back in, how do I get 1/4? 1/2 times what gives us 1/4, and that would obviously be 1/2. So the amplitude will be 2, even though right here it's a -2. Amplitude's always positive. For my students, in terms of when you need a graph, we put an up or down arrow after that. The period, we take b, which is 1/2, and when we do period equals 2 pi over b, so 2 pi over 1/2. Instead of dividing by half, multiply by the reciprocal, which would be 2. So that would then give us period equals 4 pi. C is our horizontal shift, which is 1/2, and that would be to the left. I may not be getting I may be doing more than I need to. Oh, they did say phase shift. It didn't say vertical shift, but if I did vertical shift, that would be D. Okay, so let's look at some of the next things. So x-intercept, we're going to plug 0 in for y. I think I'm going to do that in this factored form. I think it really won't matter in terms of solving. Let's go and take a look. So if I just try and separate my work here, 0 equals 2 minus 2 sine parenthesis 1/2 x plus 1/2. Okay, now to solve, we want to get this whole term by itself as our variable x is within this term. So if we get that by itself, we'd subtract 2, so that'd give us a -2, and then we have to divide by that. Just think about this as a multi-step equation. So subtract 2 divided by -2 would give us a 1 equals sine 1/2 x plus 1/2. Now we have sine of an angle. All of this, think of this as like theta. If I had sine theta equals 1, that's saying what rotation has a y value of 1. That would be pi over 2. So I take that angle, which isn't theta, it's all of this, and set it equal to pi over 2. Now if I solve, it's a matter of just solving for x. So I'm going to, instead of distributing this half, I'm going to multiply by 2 on both sides. So I multiply by 2 on both sides. This cancels with that. The 2's cancel. We get a pi equals x plus 1/2. Subtract the half over, and then I'm moving the x to the left-hand side. So you get our x-intercept of pi minus 1/2. For the y-intercept, we plug 0 in for x. So I have y equals 2 minus 2. I'm just rewriting the equation here. Sine of 1/2 times plugging in 0 for x plus 1/2. And so now we get y equals 2 minus 2. That would be 1/2 times a half, so that'd be sine of 1/4. And we could just leave it like that. And you could also write it as a coordinate, as you see on my solutions of what's posted. So it'd be like 0, 2 minus 2 sine 1/4. Domain is the next. Domain is just the inputs that give us outputs. It's a sine wave, so it's going to be negative infinity to infinity. And for the range, without graphing it, we look at that and you go, okay, well, my vertical shift is 2. So I would have my dotted line, my midline at 2, and then our amplitude is 2, so that means that I go up and down from 2. So my least value would be 2 less than 2, which is 0, and then 2 more than 2, which would be 4. And then lastly, I'm just going to put it as PS. Your phase shift would be the plus pi over 2, so that would be pi over 2 to the right, because you're adding, not pi over 2, just 1 over 2, sorry, because you're adding 1/2 to the x, and that's in the C position. Okay, so now if we want to write the equation of the graph using cosine, we need to start the wave, we need to find our A, B, C, D. It's telling us that we're going to do cosine, so we either start at the top of the wave anywhere, any of these points, or we start at the bottom of the wave down here. And given the fact that the only restriction they give us is that we want it to be cosine, it would make sense to obviously choose a high point right here, since that would make your amplitude positive because you're starting at the top of the wave. That would be preferable to have your A value be positive. And I really don't think there's a reasonable preference either way to start out the negative pi over 2. You could also start at the 3 pi over 2 or the negative 3 pi over 2, but these are smaller values, so I'm going to start at one of those. Okay, so let's make it f of x. Let's change back to the black marker. F of x, I first need to figure out my A. Let's see, so my A would be, if I go from here to there, that's -1 to, what, -5, so that means my greatest displacement is 4. Well, the midline, or the amplitude, is half of your displacement because we have a midline right there. So this is your amplitude right there, which would be 2. And again, I'm gonna decide to start at this point right here. I'm gonna make a cosine. Got to figure out the b value based on our period. Well, what's our period length? We got to go from high to high. That's the length of pi. So if our period is pi, our equation up here at the top of the graph, period equals 2 pi over b. I plug in pi for the period equals 2 pi over b. As we've done many times, we invert these two. That's just solving the equation. So b equals 2 pi over pi, which is 2. So 2 goes in there. And then again, I'm going to do my horizontal shift of this. That's pi over 2 to the right, so it's a minus pi over 2. And then the d value is the position of the midline, which is at an x value of -3, so I have a -3 on the outside. Volt problem, it says that the volts of an electrical circuit are given by that function, or that equation. Find the first time t is at a volt of 6, so I'm going to plug 6 in for V. And we'll take care of that first time after we get further in this problem. Talk about that. So here's our setup. We simply plug 6 in for V, and now we need to solve for t. So to solve for t, we have to first solve for sine, which divide by 12. So you have 6 over 12, which equals 1/2. And then you have sine of 120 pi t. Now, just like we did before, you can think of this as a theta. And if this is a theta, this is saying what angle, because we don't know what this is, what angle has a y value of 1/2. And on the unit circle, the y values that have a 1/2 is the rotations that have a y value of 1/2 would be pi over 6 and 5 pi over 6. So we look at that and we go, well, if we set this angle equal to pi over 6, that would be the first angle, or the first time in which the voltage was 6. But we don't, is that what we want? Yes, it is. So, and this would be the second time. So we want to use this one right here. So we're going to take the angle now, that's just like our theta, and set it equal to what gives us a y value of 1/2, and that'd be pi over 6. And now you have an equation where it may look a little different than we're used to, but your variable's right here and you have a coefficient out in front, multiplying by it, and you want to solve for the variable, you obviously divide, undo multiplication, so we divide by 120 pi. Since we got a fraction over here, I'm just going to multiply by its reciprocal, 120 pi. And now these cancel here, so I have t equals, and the pi's cancel here, and then we have 6 times 120, which is 720, and that's in seconds. So the first time that the voltage would be 6 would be at a time of 1 and 720th seconds. Okay, so write the equation in terms of sine. Write a sine function or sine equation given the amplitude's 4, period of pi over 4, phase shift of that, and reflected about the x-axis. So first off, let's check reflected about the x-axis. If I have my x and y axis, if I'm reflecting about the y-axis, like here's my x and y, I'm reflecting up and down, that means that we are reflecting on the outside, or y values are changing, so that gives us a negative a value. So first off, I have y equals, because I wanted y instead of f of x, amplitude of 4, but I also want that reflection, so it needs to be negative. Sine, if I have a period of pi over 4, I'm going to come up here on top and go pi over 4 equals 2 pi over b, so then I can figure out what my b is. We're going to invert those. I'll go ahead and zoom in on this. So we're going to invert these, so that's going to give us b equals 2 pi over 4, right? Because if you think of all of this as one term right here and b is right here, I could take this and invert it with all of this. You could also, I suppose, cross multiply and solve, but you end up getting the same thing as we have right here. Dividing by pi over 4 is the same as multiplying by 4 over pi. That goes away because it just got interchanged to it's being multiplied by the reciprocal. Those cancel, and then you have 2 times 8, so our b value is 8. So I come down here, I have a b value of 8. I put those brackets because I know I have a phase shift. It's to the left, so it's a plus 3 pi over 8. And I think that's all we need, as there's no vertical shift. And yes, that would be it. Ferris wheel problem. Couple of things to note. The radius of the circle is the amplitude. The height of the center of the circle is your vertical shift. Your revolutions per unit time, revolutions per second, per minute, and so on. One, make sure your units are the same in terms of what they give you for t, as well as what they give you in terms of revolutions per minute, per second, so on. Remember, that is your frequency, and then you got to convert your frequency to your angular speed. So let's see what we have here. Bottom of the Ferris wheel, and I always like drawing a diagram. I'm going to zoom this in, so you have to zoom in and zoom out. That's okay. So I have the Ferris wheel here. Bottom is 10 feet above the ground, so I'm going to put 10 feet there. And we have a diameter of 50 feet, so that means I have a radius of 25 feet. And what other information do I have? So I have 1 revolution per 30 seconds. So I have 1/30th is my frequency, so I have to multiply that by 2 pi. And that's going to give us pi over 15, and that is in seconds. And time, assume that we're at time of 0, and it doesn't look like it says anything right in terms of time being in seconds, but if you look down here at one of the questions, it says time in seconds, which is reasonable. So first off, I did find my b value right there, and let's see what else. We have the radius, so we know what a is. Our C is going to be based on where we're starting. We haven't gotten that yet. We'll get that in a second. But we also get our D, which would be the height of the center. Well, the height of the center would be all of this, which would be 10 plus 25 is 35. So if again, I'll just go ahead and write all this down. A is positive 25, at least, or well, the amplitude is always positive, but are we going to go up or down? We'll decide that in a second. B is pi over 15. C, I don't know yet. D is going to be 35 because, again, that's the height of the center of the circle, which would be the 10 plus the 25. And then right here it says t is 0, you're starting at the low point. So if we're starting here, that means if I drew my wave, we're starting at that low point of the wave. And if we're starting at the low point of the wave, 1, it would be a cosine, and 2, that would make our a value negative. So the way I have my students do it is I put a down arrow. So now let's see what variables. Are we using h and t? That's what I'm assuming. If they give us what the variable is, they do give us t. So let's just go ahead and use h, and I like writing it as a function. So let's write it as h of t equals, since again we're starting at the low point, it has to be a negative 25, cosine, bracket, pi over 15, t, c is nothing. So as I'm writing this out, I forgot that we don't have a c, it's 0, well, it's 0. So let me just clean this up here. Cosine of pi over 15 t plus our d, which is 35, and there's our function. Find the height, find your height above the ground at 65 seconds, so that's simply h of 65 equals negative 25 cosine pi over 15 times 65 plus 35, and you're simply going to be plugging that into your calculator. Make sure you're in radian mode when you do that, and you will get the solution for that. Now they're asking what's the time when you're 45 feet above the ground, or 40 feet above the ground, so that we're plugging that into the output and then solving for the input. So I plug that in for h of t, and I have pi over 15 t plus 35. Here's my variable here. This is really just a multi-step equation. So to get this term by itself, we're going to subtract the 35 and divide by negative 25. If I subtract the 35, that would give us 5 over here, equals negative 25 cosine pi over 15t. Now I'm going to divide by negative 25, so 5 divided by 25 would reduce to negative 1/5, equals cosine pi over 15t. So what I would do in your calculator, you go second cosine, it's going to look like that with an inverse, and you plug in negative 1/5, and it asks for the first time. Well, long story short, that, and note, I'm going to set that equal to pi over 15t because inverse cosine is inverting the x and y. So instead of this being your x, your input, and that being your output, the inverse, this is now your x and this is your output. This right here is going to give you a value that is 1.77, which is the correct angle. I'll talk more about in class why that is. It's not of the utmost concern. And then you solve by multiplying by 5, or 15 over pi. And when you do that, 15 over pi times 1.77 with your calculator gives you approximately 8.5 seconds. All right, for this graph, the difficulty of this is, I would put it like if, relative to the test, if you had like difficulty from 0 to 10, 10 being the most difficult, I would put this at like a, like a 7. In the test, I would put like a 5 or 6. Compared to the homework problems where you had the period change and the transformation, I would put those at like an 8 or 9 or a 9 or 10. So what we'll see here is, long story short, if we do our phase shift to pi over 5 to the right and we make that our scaling, we'll be able to fit the whole graph in here, but each of the key points won't be the key points of the graph, meaning going from 0 to asymptote, 0 to asymptote, will not just be on these gray lines. We'll have to make some intermediate scales in here. On the test, it's going to be similar to that in the sense that this phase shift is not going to be the same as the interval, meaning half of the period, but the key points will on the test will not have, you will not need that intermediate going from here, like if you start here on the test, and the next key point would be like here, and the next key point would be like here. It wouldn't have these intermittent ones. So keep that in mind as we go through this one. And sorry that was a long introduction, but I just want to kind of set the stage for difficulty and challenge of graphing this relative to what you'll see on the test. So they're very similar, but I think like this one is a step up relative to the test. Okay, so first off, our A is 1 and it's down. As I said in class, A being 2, 3, 4, 1, 10, whatever, doesn't really affect the tangent graph much because the amplitude just stretches it vertically and tangents go into negative and positive infinity anyways. But that down arrow is really important because the tangent graph, as you know, starts down and curves up. Well, since we have that negative, it reflects about the x-axis, so we're going to start up and go down. Our b value is 1, coefficient out in front of x, or even factor out of the parentheses is 1. So the period is pi over b, so it's just going to be pi. And then our interval, which is from one step to the next, is half of the period for tangent, as we talked about in class. So it'll be going up by pi over 2. C is our pi over 5 to the right, since it's minus Spider-Man rules, and then d equals 0. So we are going to, given the fact that, I'm going to zoom into the graph here. So we're going to go here at pi over 5. This is going to be our horizontal shift. And then we want to add pi over 2 to that to get our next one. So let's see what that would be. Pi over 2, pi over 5 plus pi over 2. I'm going to box this in. Now I'm going to rewrite it with like denominators. I'm going to multiply this one by 2 and this one by 5. And that's how much we're going to be going up by each time we want to get to the next key characteristic or key point, quote unquote point, because it's asymptotes every other for tangent. They're not zeros or points. So let's just kind of see if we have 5 pi over 10s. So if we start here, the 5 pi over 10s, so it's like 2 of them. So we go 5 of the, or so this is like 2, and we go 5 for every to the next key point. So if this is 2, this would be 2, 4, 5, half, and then another, let's see, what was that again? 2, so that'd be 1 pi over 5. So 1, 3, 5. So we'd have a point here, point right in here, and right here. So that's 1, 2, 3, and then 4, and then 5. See how it fits exactly? So we need 5 points altogether, and it's, if this is 2 pi over 10, again, we need 5 pi over 10 to get to our next key point. So I'll do that again. Excuse me. This is 2 pi over 10. So 2 pi over 10, 4 pi over 10, 5 pi over 10, 1 pi over 10, 3 pi over 10, 5 pi over 10. That gives us 3 of them, and then going 2.5 in the other direction. 1, 2, 2.5, 1, 2, 2.5. So it fits. So let me go ahead and just scale these. So that's a 1 pi over 5. This is a 2 pi over 5, 3 pi over 5, 4 pi over 5, 5 pi over 5, which is pi, and then 6 pi over 5. Going the other direction, this is a negative pi over 5, negative 2 pi over 5, negative 3 pi over 5, and negative 4 pi over 5. It'd be nice to have these intermittent ones too, because we're going to have key points there, but I think we can skip that. We'll go ahead and make, you know, little scalings here, and then we're just going to have to know that's halfway between it. So it'd be like 3.5 pi over 5, which multiplied by 2 would be 7 pi over 10. Okay, so first, that's where I'm going to do it as green. or I'll do it kind of like as a shaded line. That's like our new y-axis because of our phase shift. This is still our vertical axis. So for tangent, we know that the first point, or the first part of the graph, is going to be a 0. And then we have our intermittent ones here, like I said. And so our next one is 2.5 of these. So 1, 2.5 right there is where our asymptote's going to go. So I'm going to put my asymptote here. And then I go 2.5 from there. 1, 2.5 gives us my next 0. And then same in the other direction. 1, 2, 2.5. Well, let's first make these. So 1, 2.5. It's going to be an asymptote. We got some background noise. The kids are playing outside the door. And then another 2.5 in that direction. 1, 2.5. That'd be a 0 as well. Okay, now since we have the key points and we have our asymptotes, we now go ahead and graph. Again, the amplitude right here was -1, which means it flipped the graph. So instead of starting down and going up, we're going to start up and go down. So if we're starting from here, we want to kind of have that nice curve to it, kind of like a cubic. I joke and call it a tubic since it's a tangent graph. And of course it isn't a cubic, it's a tangent graph. Cubics don't have asymptotes, but they kind of look like each other. So again, this next full interval, we're going to start up and go down, and you know you're sketching, but you want to kind of bring it over to the asymptote as best as possible. I mean, like this, bring it as far close so it looks like it's having that asymptotic behavior. And then same over here. Okay, and now we can answer the subsequent questions if we have any. It doesn't, but we could certainly do that in terms of like zeros, asymptotes, and things like that we can cover in class if necessary. Okay, so now move on to graphing a sine graph. First, let's go ahead and find our ABCD. A is going to be 1 up, since it's not negative out front. B is 3, so I'll give us a period of 2 pi over 3. C is 0, and then D is, I'm going to go like this, 2 down. Not confuse ourselves with the negative and Spider-Man rules, you know, we go in the direction on the outside of the positive or negative, but nonetheless, just not to confuse, I like using the down arrow. If you put a -2 there, obviously it wouldn't take off. So since we don't have a horizontal shift, we can count over and use our period length, which is 2 pi over 3. So if we start from here, we go 1, 2, 3, 4, and we're going to put the 2 pi over 3 there. So you have 2 pi over 3. And halfway to 2 pi over 3 would be right here, which is 2 pi over 6, and 2 pi over 6 reduced to pi over 3. And then half a pi over 3, same as multiplying the denominator by 2, gives us a pi over 6, and now we have our interval. So we go 1 pi over 6, 2 pi over 6, 3 pi over 6, 3 pi over 6 reduced to pi over 2. That was that skill of dividing in half and counting up. More importantly, that skill of when working with radian fractions of keeping that non-reduced in your head and writing the reduced down on paper. Okay, so now we need to get the amplitude. So we're going to go at 2 and see if that works for us. So if our midline's at 2, we have to consider the amplitude that we go up and down from that midline, the amplitude value, which is 1. So I simply ask myself from here, can I fit on the graph if I go up 1 and down 1? Obviously, yes. So we're good. Just for the visualization, here's the beginning of our period. And sorry, girls have their friends over and are screaming. They're having fun, so it's all matters. Okay, so we have sine with a positive amplitude. So this is our new quote-unquote origin. Sine starts on the midline. So I'm just kind of making that a really big point, just trying to make it obvious. And then we go to the next interval, which is pi over 6, and since it's positive, we go up. And then the next interval, we go back down to the midline, then back down again, and then back up. And we draw the sine wave. So once this defined period, which we found, domain is pretty straightforward. Always negative infinity to infinity. Range, just looking, goes from 1 to 3. Equations of the x-intercepts. If you look, that graph is never going to hit the x-axis. So x-intercept is the null set, or you say none. And that would be it. Solving trig equations. Different ways we could look at this one. I like looking at this one by just setting sine x equal to cosine x. I'm just trying something. And then that's saying sine is our y value and cosine is our x value. So it's saying where on the unit circle, I'm just going to draw this out. This is kind of like logically thinking through it. Where on the unit circle is our x and y the same? Well, at 45-degree rotation, they're the same. And at or pi over 4. And then a 5 pi over 4, they're the same. These would not be correct because they are opposites there at the pi over 4s. So our answer, x, will simply be pi over 4, comma, 5 pi over 4. If you wanted to tackle it a different way, you could go, once I have this, I have sine x equals cosine x. And if I divide both sides by cosine, cancel, that gives us a 1, and that gives us tangent. And then you ask yourself, where is our y over x the same? That's what the definition of tangent is relative to the unit circle. And it gives you the same thing, pi over 4, 5 pi over 4. Okay, so for number 9, this is where we think of all of that 4 theta as our angle, and we're asking what angle has a y value of negative root 3 over 2. So mechanically, like I said in class, just like the procedural, you take whatever your angle is and move it to this side of the equation. You have it like this. And where is our y value negative root 3 over 2? Well, first off, our reference angle, where our y value is root 3 over 2, is pi over 3. And then sine is negative in the third and fourth quadrant. So a pi over 3, oh, and sorry, we're in degrees, not radians. So 60 is our base angle, so we want a 60-degree rotation in the third and fourth quadrant, since that's where sine is negative. And that would be a 240 and a, what would that be, 300. So 240 degrees and a 300 degrees are 60-degree rotations in the fourth quadrant. But we also have to put this plus 360n, because when what we talked about in class is 4 theta, that condenses our period. So really quickly, just imagine it graphically. Regular sine graph goes to 2 pi. If we have 4 theta, our period's pi over 2. So we're going to have this sort of thing happening. I didn't draw that 100% accurately. But from what this is saying is if we condense our period, that means from 0 to 2 pi, we're going to have 4 times the amount of solutions than if we just had this angle as theta. So how do we figure out all these other ones? We have to figure out how much we go up by from one period to the next, and that's what this term does for us right here. So coming back over here, if we divide by 4 on all terms, this is going to do the first one completely, and then work on the second one. That would end up giving us theta equals 60 degrees plus 90 degrees n. So now if I list them out, I would go 60 degrees, and I'm going to add 90 to it until we go over 360, and when we go over 360, I'm not going to write it. So 60 plus 90 is 150, and then I'm going to add 90 again, which would be 240, and I add 90 again, that would be 330, and if I add 90 again, that would be over 360, so we're done right there. If you look at, we have 4 times the amount of solutions of what we did before, which is what we predicted, based on the fact that we have the period condensed by a fourth relative to our initial sine graph, and therefore we have 4 times the amount of solutions from 0 to 360. Continuing on with this, doing the exact same thing that I did on the first one. I have theta equals, let's see, 300 divided by 4 is 75, plus 90n, 90 degrees n. I can put theta here equals 75 is our first one, plus 90 is 165. Another 90 would be 255. And then another 90 would be 345. And so all of our solutions listed separately or all together. Just keep that in mind in terms of like a multiple choice. Maybe being able to maybe put those all together so nice neat ascending order. But you will have one in the short answer like this. Comparable level of difficulty as well. Number 10, same thing on the short answer. I'm almost positive there's one like this as well. This is a quadratic, and it's definitely a factorable quadratic. Of course, if it wasn't, we could check it by trying to do MAF. So two numbers we're looking for, multiply to be -4 and add to be 3. That'd be 4 and -1. So we go ahead and throw those in, and our variable, instead of it just being x or a, it's cosine x. So we have cosine x plus 4, cosine x minus 1. If I set both those equal to 0, I get cosine x equals -4, and then I get cosine x equals 1. Cosine x ranges from 1 to -1, so that's extraneous solution. And for the second one here, we say what rotation has an x value of 1? Where's our x values 1? Those are at the rotations that give us x value 1 are 0 and pi. And just be careful up here, it has an equal to for 0. So 0 solution is what we want, and not the 2 pi's. It says less than 2 pi, not equal to. Coming to number 11, add 3, divide by 4. First to get the cosine squared term by itself. And that would give us that right there. Square root cosine theta equals, we get our plus or minus, square root of 3 on top, 2 on the bottom. So what rotation has an x value of all the root 3 over 2's? Because we have the positive, we take care of for cosine the first and fourth. Negative would take care of the second and third. So we have all quadrants, and that rotation is a pi over 6. So we're looking for pi over 6 in all of our quadrants. It should be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.